Hello and welcome to my quick start video tutorial on how to use the FMC API Python package that I've created here. So first of all, how do you get it installed? Well, it is part of the PyPy or PyPI package system, so you can issue the pip3 install command, pip3 install FMC API, or if you have it, it's very unlikely, but if you happen to have an older version, you can use the pip3 install -u FMC API command. Now, those of you, I'm on Linux, so you might have to do like a sudo space -h in addition to that. If you are fancy enough to use the Python virtual environments, well, you can probably figure out how to install a package. So I won't worry about that too much. However, another good piece of information, especially for you programmers out there or people who would like to modify or improve the code or help out with the project, you can go to my GitHub webpage, github.com/daxm/fmcapi, which is this URL over here, to get more information. The other piece of information you may find here that you'll find valuable is this testing user script, which I'll show you over here in my IDE. But this gives you some sample code to start working with. Because if you do the pip install, all you're going to get is the files that are in this FMC, whoops, I clicked on that, FMC API folder. And that's, well, just the bare essentials of the package itself. So I have another file, or actually, you know what I need to do? I need to do this. I have another terminal open here, and into that same folder, my working directory, because when I run this testing user script, it's going to create an output.log file. Now I already have one. Don't worry about it if you don't already have one, because it'll automatically get created. But for those of you who are on Linux, you can use a really cool command, tail -f, the file name, output.log, and then if you put an ampersand after it, what tail does is reads the by default last 10 lines of that file, but as more data gets put into it, it'll actually update that screen. So you'll see that this screen will actually change as we add more data, or as I run the script, you'll see more added here. As you can see, I ran it before I started recording as a quick test. All right, so over here to the code. Again, this is that testing user script .py file that I said you can get from GitHub. It's not mandatory by any means, but I wanted to show you some of the essentials required to actually get the program up and running. First thing you need is to import in whatever package file or whatever Python file you want to use. You have to import the package. So from FMC API import star, and this will import all the available package or the package files that are methods or classes that are needed that you have access to that you can use to be able to interface with the Cisco Firepower Management Center's API, which is what this is all about. Some key information that you'll need to set up in order to do this. Of course, you're going to have a Cisco Firepower Management Center, and in this case, I'm using a test server I have at 192.168.11.5. I set up a test user API script, and the reason I do that is that the FMC only allows one simultaneous login per user. So if you log in as admin on the FMC GUI and then try and run your scripts as admin, somebody's going to get logged out and you're not going to have a good experience. So I'd strongly recommend you set up your own, set up a specific user for running scripts. And I use the default admin123 password. This auto deploy faults is important because I do have a function, or do have the ability for you to deploy any changes that are made to the FTD that would affect a device managed by that, sorry, not FTD, FMC, you can see where I'm going. You can actually deploy those changes that were made to the FMC if those changes affect a device managed by that central manager, the Firepower Management Center. And of course, I slipped and said FTD, which is one of the types of devices that get managed. Now, I will say that the only device I've ever tested this with is an FTD device, Cisco's next generation firewall, but I do know that the FMC will also manage Firepower appliances, which is Cisco's IPS. I just haven't had one to test it with. Okay, so let's go into the quick start stuff. Sorry to take forever to get started. You'll notice I'm using the with syntax. Now this is a Python command that kind of does some logic on the back end for you, and I'm specifically using that when I instantiate an instance of the FMC class. Now I'll show you the code when we get into the fmc.py file here, but effectively this FMC class is going to get past these variables, and an instance of that FMC class called FMC1 is going to be created. Now as long as I have the rest of this code indented, I'm in the block code of the with statement. Now what the with statement's going to do for me is it will look in the FMC class for particular subroutines. One's going to be called the enter or dunder enter, is as we say in Python, subroutine, and that's going to do some stuff as we instantiate this FMC1 entry, and then there's this exit subroutine, the dunder exit subroutine, that gets run once we stop being indenting our code here. And I'll explain more about how those work when we actually look at the code. But in short, what I've done here is I've just set a name, so you can see when I highlight namer here, it's being used throughout my little subroutines here, and this is my mega test. What I've tried to do here is I've built kind of little unit test system that goes through and tests all my classes that I've created, so that you can see all that can be done. Now I'm not going to go into all detail here, but let me start down here with like this IPHost one. I will give you a quick surmise of all the classes when we look at the code, but I want to show you kind of two main areas of how this thing works. So first of all, in order to access one of these classes, you have to assign it to a variable, and effectively what you're doing is creating an instance of this IPHost class. Now there are several variables, and I'll show you an example of it down below. There's several parameters that you can pass to each one of these, but the minimum required is you have to tell this object what FMC it's associated to, and that's one of the reasons that this code is blocked in underneath this with statement, is that I have to have that instance of FMC1 in order to do this. Now the reason I set it up this way is that technically you could have two, not with the with statement, but you could have two FMC instances. Maybe you'd want to transfer files from one FMC or configurations from one FMC to another. Now I haven't tested this, but I don't see why it wouldn't work. But I could have an instance FMC1 and an instance FMC2. I could instantiate one of these, well, here, let me go back down to IPHost. I can instantiate this IPHost, an instance of this IPHost class, and then go get all the values that are on this FMC number 1. Then I could change the FMC value to FMC number 2, FMC2, and then post those values, effectively pulling from one FMC and putting on another. But that's kind of advanced for what we're trying to accomplish. Now, how this works. So you have to instantiate it, and you have to, the one requirement is you have to give it the FMC that it's associated to, and then you can just use the name of the values that you want to use. IPHost is very simple. The minimum requirements, you have to have a name for the IPHost, the entry, and you have to have a value. Now a host entry has a /32 or /128 if it was IPv6, or no bit mask notation at all. If you use another one of those, it will actually take it, but throws a warning at you. And then, so you can see I've instantiated a bare instance of the class, I've given it a name, I've given it a value, and then I've used the post method to actually push that data up to the FMC1 object. So up until I said post, all this computer code, all this code actually only resided inside my computer program as obj1. And then through my unit test, what I do here is I delete that object. I know I don't have to, but I do it anyway. I create another IPHost instance, and notice that this time, just for fun, I put name equals namers, because basically what this is going to do is I'm going to create an object associated to that FMC, but I know that the name I want to give it is this namer object, which just happens to be the same name up here. I'm going to use the get method to be able to pull. Basically, I'm going to go ask that FMC1 FMC, hey, give me your IPHost object that you have that has the namer, whatever namer is. Okay, and as you can see, I'm setting it up here to be underscore FMCIP underscore test underscore, and then a time string here. So it's, this could be, whatever. It doesn't really matter what the name is. I'm using the get to populate all the data from the FMC, like I just said. And then notice that I'm going to change the value. So the value used to be 8.8.8.8. I'm changing it to 9.9.9.9. And then instead of the post method, because it's not a creation of a new instance, it's an update of an existing instance, I use the put method to be able to update those entries. And then finally, again, part of my unit test, I'm just deleting that object out of the FMC altogether. So if you really think about it, this unit test from an FMC's point of view does nothing. I create an instance of it, I go get that instance, I update that instance, and then I delete that instance. And all I was trying to do here is test all those features. Now, if I come down a little bit further, you can see that I have all sorts of tests here, and I'll cover all these a little bit later. But what I wanted to do is come down and show you a little more of an advanced scenario here. So in this block of code, what I'm actually doing is setting up a bunch of variables. Since all these up here that I built, I created them, got them, or created them, posted them, getted them, putted them, and then deleted them, there's really no change in the FMC during my testing. So down here in this block of code, I'm actually creating a whole set of objects so that I can utilize them in the next block of code, which is dealing with access control policy rules. So I'm creating an IP host, an IP network, an IP range, all the different variables that I can possibly set up or objects inside the FMC I'm trying to build. But the point I want to try to get at here is that notice that in this set of code, I'm using about the smallest amount of lines possible. So I'm building an IPHost 1 instance of the IPHost object, and I'm passing all the variables I want to give to it in the actual instantiation of that object. So name equals value equals. And then immediately after that, I'm posting that to the FMC. So effectively in these two lines, I've created the values that I want to put in the FMC, and then I'm posting those values to the FMC, saving you as the user of this all the hassle of dealing with how to format that JSON data structure to be able to do that same thing by hand, either through the API Explorer that's available in the FMC or writing your own Python scripts. I mean, that's the whole point of this FMC API. Now you can get a little more advanced, and here's an example where I'm actually cheating just because I know what to do. I'm actually cheating and throwing in a little bit of what would eventually end up being JSON code that I do know that when you create a VLAN tag, it requires a name value, and it also requires a data value. Now, VLAN tag, you would think it's a single VLAN, but actually the way the FMC set up, it's a range of VLANs by default. So I have the start tag and the end tag kind of like sub options of the data value, and that's a minimum requirement to be able to create a VLAN tag. Again, I'm instantiating an instance, and then I'm posting that instance to the FMC to be able to build these objects, so on and so forth. Now let's get down to the meat and potatoes. This one's probably the hardest one, and that is dealing with an access control policy rule. Now, if anybody's been working with FMCs and specifically with firepower threat defense devices, FTD devices, you'll know that there's a lot of options that you can work with. And I've really tried to capture as many of them as I possibly can. The two that I know that I don't have, I'd like to get done, is dealing with URL, not objects, but URL categories and reputations, and then applications, right? Like SSH or FTP or I don't know, some other application-based acknowledgement in the access control policy rule. Here I'm just dealing with the easy things I can set up. In order to do an access control policy rule, though, you do need to set the FMC like we did before, but an access control policy rule is actually a subset of an access control policy. Now, there are two ways you can do this. This way I'm assigning it during the instantiation of the access control policy rule. I don't think I did it up here. This is kind of an example of it. I don't even know, what am I working with? Oh, a device. This is where I'm creating a device. You can do an access control policy rule kind of like this as well, where I instantiate the FMC, I give the access control, in this, pretend this is an access control policy rule, I give it a name, and then I use the, actually this would be ACP underscore name, then I use that name to get the ACP, the access control policy rule, ID associated to that name. Well, I'm kind of cheating when I come down here and do that, and not cheating, I'm use shortcutting, I should say, by doing this all in one step by saying the ACP underscore name is this name, which is the access control policy I just created up here, um, in the step of instantiation. I could have done it as more steps down here, but I was trying to speed things up. I don't know why you would ever do it separately unless you wanted to move from one access control policy to another. You're moving a rule from one place to another. More than likely, you'll want to type it up like this. And then the access control policy rule, I'm giving it a name, an action, I'm setting it the enabled to false, setting all these are essentially, I don't want to say, some of these are Boolean, but all these like really simple objects I'm setting up as you would with these other objects that we've already built with. But starting here on line 213, you can see that we're doing something way different, okay, in this block of code before we actually send this newly created rule off to be programmed into the FMC. So I have these subroutines of the access control policy rule class, the ACP rule class, variable set, and then it's an example here, and I have two values, action, and then the name of the action you want to do, okay, or the name of whatever it is that you're trying to accomplish. So a variable set is actually kind of a Boolean. It's either set or cleared. I mean, there's only one option, but just like up here with the VLAN tag, the JSON code that's required is a little more complex than just setting a single variable. So I set this subroutine up for you. So you say set, and the one I want to set, the variable set that I want to associate to this access control policy rules name happens to be default-set. So set the variable set to this, whatever variable set has this name. Set the source zone, or I'm sorry, not set. So now source zone, you can have multiple source zones, multiple destination zones. So instead of set and clear, you have add and remove and clear, right? So clear just clears it all out, like deletes all the in this case source zones, right? So in this case I'm saying action add, and I want to add this particular security zone underscore SZ1. Again, I created it up here as part of this project, saying I want to add the underscore SC1 zone into the source zone setting of this access control policy rule. I'm just testing things, so I did that same thing with the destination zone. Intrusion policy is again like variable set, where it's a kind of a Boolean. It's either you can only have one IPS policy per access control policy rule, so it's a set and clear are the two options. Add kind of gives you the implication that you can add multiple of that particular type to that one single entity or that one single rule. So that goes along with VLAN tags, source and destination port, source and destination networks. I'm adding two, right? So I'm adding, in this case, I added a underscore IPHost 1 to the source network and underscore IP range 1 to the source network, to give you an example of how you would do that. And then finally I post it to the FMC and it builds that access control policy rule. And then lastly in my code, because all these rules exist, I didn't delete, or all these instances of all these different classes exist, I haven't deleted them yet like I did up here with the OBJ1. I can now go through and delete those. So notice that I delete them in the reverse order. You can't delete a host rule that's being assigned to an access control policy rule, so I kind of did them in the reverse order. So we're deleting the access control policy rule, we're deleting the host 1, net 1, range 1, so on and so forth, all the things that I used. Now I'm going to click go on this just so I want to show you what the log files. See, you won't get much output over here. There is a few things that in my test I do output because they are used to return like a listing of everything. or you can't really do anything but get the information. So instead of actually, I don't know, putting in a log file or doing something, you'll notice that I'm just printing this to the output, right? So here's our all the IP addresses, all the networks. That's either IPHost, IP network, or IP range values. It's just a big long list. If I scroll to the right, you'll see it's a nice long list. And then this next one is the variable set, or the variable set that sits out there. All the rest of these are slowly doing something in the background. Now we don't see it here because we're not looking at the log file. But if I flip this over, you can see that it's actually going through and creating these, logging, I should say, telling you what's going on. Now, the output.log file is chatty, and I'm not a Python logging expert. In fact, I should throw out here, I'm not a professional Python programmer. I'm a content developer, a security / route and switch Cisco engineer, right? I work with routing and switching and firewalling, and not Python programming, but I've had the opportunity to build this, so I've put forth the effort. So anyway, please don't expect absolute pristine perfection. I know it works to a value that I feel comfortable with, but that certainly doesn't mean that it's perfect, and I apologize for anything that doesn't work right. Feel free to help me. Either do a pull request, or pull request to me if you've made a change, or email me updates or fixes, whatever it is that you would like to see. I'd be more than happy to work with you on that. So as you can see, when going through here, that's one thing I didn't show you, is you can add in the test device, in the device section, you add licensing to it, right? So I can add and remove licenses. You can see here I added the malware license, I added the VPN license, then I removed the VPN license, then I removed all the licensing, and then I re-added the base license just to get the test done. And finally, let's see, we went through and we built the access control policy rule. I know this because I see a bunch of deletes at the bottom, and our script is now done. So that's kind of an example of how this works. Now, that's the test user script. This is something that you guys would either create or modify to do whatever logic it is that you want to have. Here's the under the hood. Now, I'm not going to go into super detail, but I just wanted to show you really quickly. Inside the FMC API package, there's a fmc.py file. There's some other files, but this is these two, the API_objects and the FMC modules, are the ones I really want to focus in on, because these are the ones that you would have access to from the outside world. First of all, there's the FMC class, which we've seen. That's the one that gets instantiated with the with clause. And when I get in here, remember I said that there was that enter subroutine? There's one called, it's *enter*, and in Python parlance, the way you say that is dunder. So dunder enter is the way you would call this. And what I'm doing in here is creating and instantiating that token ID. If anybody's worked with the FMC API at all, you have to build a token, and then that token is used for all your gets and puts, posts, and delete messages you send to that API. I've got a subroutine, or I mean a class down here, this token class, that does the whole management of dealing with that token. It'll refresh the token, it'll re-authenticate you if you wait too long to call in again. So all that harder logic is all taken care of for you. But initially, I build the token. And then when you're done, when you exit that block of code of the with statement we talked about at the very beginning, this dunder exit method gets called. And what happens in here is where that auto deploy, if you set auto deploy to true, then it's actually going to go gather a subroutine called deploy changes. It's going to go gather all the get deployable devices, and then it's going to push those changes out to the corresponding devices, FTD devices or whatever that you have, to help you actually deploy changes automatically. So you can go in here and work on the logic of what you want your objects to contain, their values and how you want them set up. And the FMC API will actually build, maintain your connection to the FMC, and then when you're done with that connection, if you choose, automatically deploy those changes to the corresponding objects that are being affected. And then, as you saw before, we have a whole bunch of classes that we've created, and some of those classes have subroutines in them. I'm just going to quickly cover them. The IP addresses class is effectively is a way of getting all the host, network, and range objects out of the FMC. Again, this one only supports the get feature. That's that one that gave us this huge long list over here as a print output. The IP host, the IP network, and the IP range work very similar to each other. I don't know why Cisco broke them out this way, but each one of them is subtly different from each other. And if you try and send the wrong one to the wrong, if we try and get let's say an IP range network, an IP range, a name of a network object that's an IP range, but you use let's say the IP network get feature, you won't actually get the return of it. It's kind of weird the way that works. So when you're in the FMC and you look at your objects or object management host tab, or menu item, you're going to see all the IP addresses, but they're actually broken out by type into these 3 different categories. Too much TMI, I know, but I just want to let you know why that's broken out that way. You can create URLs. These are the custom static URL entries. You can create VLAN tags. I know I talked about that. Variable sets. This is mostly a get form to be able to get what the variable set is that's programmed in the FMC. You can't create them yet. You can just get. Protocol port, this is your ports. Really, it's port and protocol, right? So it's TCP port 80 or what have you. Technically, the type inside the FMC is called protocol port. That's why I called it this instead of just port. Security zones, no surprise there. Device, this is mostly for registering a device, but also eventually someday down the road I hope to be able to modify the device, set up a static route, set up the interfaces with their appropriate IP addresses and what security zone that they're in, but I haven't written that part of the code yet. Intrusion policies, again, this is just a get method. The API doesn't allow you to create new intrusion policies. It just allows you to get the ones that exist. Access control policies and access control policy rules. Now, when I look in the access control policy rules, remember there was all these other sub methods. So if you really want to get in the weeds, this is the method that gets you, or the subroutine that gets you, that gets used to call a particular access control policy by name so that we can get the access control policy ID so that we can associate this access control policy rule to that access control policy. I know it's a mouthful. Our intrusion policies, remember, it's kind of a Boolean. It's either set or clear. Same thing with the variable set. And then all the rest of these, source and destination zones, VLAN tags, source and destination ports, source and destination networks, you can add multiple you can have multiple source networks, multiple destination networks. So the actions here are the add, remove, and clear options. I believe that's everything. So feel free to give it a try, download it, and if you want it, go get the testing user script from from the GitHub URL. I'll post that one more time. Now I'm new to posting to YouTube, or rather it's been many years since I have last posted. I will try and put this stuff in the notes underneath this YouTube video, but if not, at least it's posted here. Thank you for your time.